We're gonna go over standard form some more. We've been whoopsie daisies. We're so used to slope intercept form. Um, you know, Let me just refresh you really fast on that. But we've been working with that all semester, and hopefully you know what it is by now, right? Mx plus b, or since it's commutative, you can say y equals b plus mx, right? So some examples are like stuff we know how to graph and stuff we've been working with all semester, right? It can be in this order too, or it could even be like 4x minus 3 equals y. Doesn't matter how it's put, but it's all the same thing. Let's make it negative 1 half x minus 3, right? These are all examples of slope-intercept form. Every single one is, okay? But now we've been learning about a new form, so let's go over that one. That's called standard form. Standard form. Okay? And that's going to be in this form, ax plus by equals c. And it's also a straight line. It's just written a different way. So, 3x plus 2y equals 6 is an example. 4y, it can be the other way around too. Minus 2x equals 12 is an example. 12x plus 3y equals 36. This is also an example. So these are all examples of equations in standard form, okay? And we always go about solving it like this. We always make a table, okay? And we say x-intercept, y-intercept. Okay, and we always set the opposite to 0. Now, I don't want to just tell you that. I want to kind of convince you that that's true. But see, this will be our setup for all the type of problems like this. This is what's important. But let's find out why that's actually true. Now, let me get a graph out here for a second. Let's see. Okay, so watch this. If I have a graph, here's one, here's another one. Let's make it xy, right? Just label the axes. Okay, now let's show some examples of lines. Now watch this. This is kind of interesting. So let's say this is one line, this is another line, this is another line, and let's say this is another line. Okay? Let's find out what all the y-intercepts are. Now this point right here is a y-intercept. We could say it's 0, 3. Okay? This one is going to be 0, 1. Right? This one is going to be 0, negative 3. And this one's 0, negative 2. Now what's important here, now look at this, guys. For every single one, any single possible y-intercept, x is always 0. Right? X is always 0. X equals 0. Right? For y-intercepts. And that's exactly what we said in our table, right? That's exactly what we said right here. For the y-intercept, we're going to set x to 0. So that makes perfect sense. I mean, the y-intercept's always going to be 0. For x, the x value is always going to be 0, right? No matter what line you do, come up with lines yourself, you'll see that this case always holds. Okay? Now let's try to see the case with x-intercepts. Same exact logic. Okay, same exact logic. Let's go make a line right here, another one right here, right? This is going to be x. This is going to be y. So x-intercept is going to cross the x-axis. Let's come up with a few different lines. So we have, let's make it one here, one here, one here, and then one here. Right, so let's find out what these are. This is going to be negative 5, 0. Right, this x-intercept over here is going to be 1, 0. Okay, this one right here is going to be 2, 0, and this one right here is going to be 4, 0. So in this case, look, y is always 0, right? So y is 0 for x-intercepts. Okay? So it makes perfect sense, and that's what we said here, right? For x-intercepts, we're going to set y to 0. So I'm just convincing you that it's true. Now let's go over some actual examples. Let's change this background to a chalkboard green. Okay, so let's go over just a couple of examples now. If we have 4x plus 2y equals 8, here's how you want to go about setting it up, right? We went through the setup before. We want to have this, right? We'll call this our x-intercept, y-intercept. Always set the opposite to 0. Right, now it's just a matter of plugging in, you know. So 4x plus 2 times 0 equals 8. 4x equals 8. Right, so x-intercept is 2. Right, we can just kind of circle that. Same thing here, except we're plugging in 0 for x. 4 times 0 plus 2y equals 8. Right, so 2y equals 8. So our y-intercept is 4, right? Let's go over one more example where we actually not only solve it, but we graph it, okay? So let's go over one more example. Okay, so let's make it 2y minus 3x equals 6. And we're actually going to graph this at the end. So same exact setup, right? X-intercept, y-intercept. Okay? Set the other one to 0. Now I'm just going to do this mentally. So since y is 0 here, I get negative 3x equals 6. Right? So x-intercept equals negative 2. Right? And let's do a little bit of work here. So x is 0, so 2y minus 3 times 0 equals 6. This goes away. 2y equals 6. So my y-intercept in this case is 3. Okay? Now we got to actually do the graphing. Let's actually graph this guy out. So we have our two axes here. Right? Let's make it x, y. So our x-intercept is negative 2. That's going to be right here. Y-intercept is 3. That's going to go right here. Now let's connect the line and we're done. I don't want to use that color. Let's use purple. Right? We're done. It's going to be like that. Okay?